are going to be continuing on with our Unit 4. And today we're taking a look at the lesson 7.5, linear inequalities. Intro question: just as you have used inequalities to describe graphs on a number line, you can use inequalities to describe the regions of a coordinate plane. So let me show you what that looks like. First, for the number line, if it says x is less than 1, that means we're going to put an open circle at 1. Does not include the equal to sign, so we have the open circle. Less than, so the numbers that are smaller, which is to the left. For graphing it, if we were graphing the graph x equals 1, that's an extreme line. So you're going to have a line going vertical, and it's crossing the x-axis at 1. Now notice it says less than, so I would have a dashed line. We'll get into more about that later. Once again, less than, so it's the ones that are less than. That's how we do it on a coordinate plane. Okay, let's take a look at some vocabulary real quick. A linear inequality is a mathematical sentence that describes a region of the coordinate plane having a boundary line. Each point in the region is a solution of the inequality. The solutions of an inequality are the coordinates, of the points that make the inequality true. Okay, take a look over at our graphic organizer. For here, the rules for graphing linear equations. First, graph the boundary line. Write the line in the form of y equals, just because that's what you've been used to using. Then we'll look at what the inequality says to see what we're supposed to do next. So looking here, we have if the boundary line is included in the solution, see how it has the equal to sign with the inequality? Then it should be a solid line. Example, y is greater than or equal to 3. So for thinking of the equation y equals 3, first of all, we know we're going to have a solid boundary line because it includes the equal to sign. So at 3, 1, 2, 3, at y equals 3, lazy line, so it goes sideways. Step 2, second, shade above or below by the boundary line. Well, let's see, this one says greater than. Down here it says greater than or equal to, you shade above the boundary line. So I'm going to shade above. So if I picked any point up here, it would work that it would be greater than or equal to 3. For the next one, if the boundary line is not included in the solution, it's less than or equal to, notice less than or greater than, notice it has no equal to sign, then it should be a dashed line. So for example, y is less than 2x plus 3. You can think of it as y equals 2x plus 3. You know how to graph that line. Our y-intercept is 3. Slope is 2, up 2, right 1. Now when you make your line though, you need to be careful. It is less than. It does not include the equal to sign. So when we graph this, we need to make it a dashed line. This is our boundary line, making it dashed. Then, second step, shade above or below the boundary line. For an inequality written in the form of less than, which this one has, shade below. So we're shading below the boundary line. Okay, going on, example number 1. Equation for the boundary line is y equals 3x minus 1. You know how to graph that. Y-intercept is negative 1. Slope is 3, up 3, 1, 2, 3, right 1, up 3, 1, 2, 3, right 1. Now, we need to figure out how we're going to make this line. It is greater than or equal to, so it's going to be solid. So it includes that equal to. For shading, it says greater than, so we're going to shade above the line. There we go. Next one, example number 2. First, we need to get this into y-intercept form so that we can actually graph it. So just like we've done before, subtract 4x from both sides. So negative 3y is greater than negative 4x plus 6. Now divide everything by negative 3. All right, now taking a look at this, here's a tricky thing right here. Let me show you. So it's going to be y. Now here's the tricky thing when we solve it. Put it over here. This sign, since we are dividing, this only works when you're dividing by a negative. When we are dividing by a negative, we need to flip that inequality to face the other direction. We are flipping it because we are dividing by a negative. So it's going to be y is less than negative 4 over negative 3 reduces to 4/3 x, and then minus 2. So once again, so we were dividing by a negative, we had to flip the inequality. So just to graph the line, it's y equals 4/3 x minus 2. So y-intercept is negative 2. Go up 4, 1, 2, 3, 4, right 1, 2, 3. Okay, it is less than, so I'm going to make it dashed. And then shading. It says less than now, so I'm going to shade below. So you might want to write yourself a note right here when you're dividing by a negative. Dividing by negative, flip sign. Okay, next one. For this one, first we need to once again get it in slope-intercept form, so let's subtract 8x from both sides. We have 6y is less than or equal to negative 8x plus 12. Divide everything by 6. Notice we're dividing by a positive, so we don't have to worry about flipping that sign. So we're going to have y equals, I'm just changing it so that it's easier to graph it, and then we have negative 8 over 6 simplifies to negative 4/3 x, and then 12 plus 12 divided by 6 is 2. Okay, so let's graph that line. So we have y-intercept of 2, slope is negative 4/3, 1, 2, 3, 4, right 1, 2, 3. It includes the equal to, so it's going to be solid. The inequality now, let's take a look at what that looks like to know where we're going to shade. Let's see, it includes the equal to, I'm sorry, my bad. It has less than, so since it has less than, we're going to shade below. Okay, so remember, you might want to take a look at this. For shading, it's down here. If we're talking about solid or dash, it's going to be up here. You can refer to that when you're working on your homework.